Hello, so I'm Stephen Trowell and I'm the founder of PPB Technology, and as it says there, I'm going to tell you why evolution is cleverer than we are and how we're using that to build better biosensors, which is what that says. So let me tell you a little bit of a story. This is actually about the food industry, but it could be several other industries. This is what a future customer said to us. Our products are on the supermarket shelf before we know they're safe. Is that not scary? Was his words verbatim. And what's happening there is the food industry is taking samples for safety and quality testing. They're sending them to a laboratory that's far away, and then they wait for up to a week, actually on average a week, to get the results back. By which time many products have been shipped, they've been sold, they may have been consumed. So this is the problem, that the just-in-time supply chains we deal with these days, they're not fitting with the model of laboratory testing that's been around for 50 years. So it's not that these people are reckless, they're taking lots of precautions, they're following all the rules, but they're still working blind. So that's our problem. What are we going to do about it? Well, the problem, I just say, can be pretty serious. So in the worst case, terrible things happen. So a lady called Celia Marsh, 42-year-old dental nurse, walked into a shop, an outlet just like this one, premium outlet in the UK and England. She bought a wrap that was supposed to be dairy-free, and it wasn't. So she had an anaphylactic reaction, and tragically she died in hospital shortly afterwards. So that catastrophic event is rare, but it's not unheard of, and there are a range of other quite common adverse events as well. So that's what happens when the testing system and the safety system goes wrong. And this is what we're doing about it. So let's switch tack to the 3.5 billion years of protein evolution on this planet. And from that, we've got millions, probably 8 million or more, different protein structures out there in the living world, many of which bind to the things that we care about, the things that are going to cause problems to us, whether that's an anaphylactic reaction or toxic reaction. And so what we can do is go to a bacterium like that happens to have a sensor that works better than the person in the lab coat with the expensive machine I showed you on my second slide. And what we do then is we take the protein. So you tell me there's a target that you're interested in detecting, whether that's an allergen or lactose or it's a nutrient. We will find in nature the protein that binds specifically to that target, and we wrap around it a blue light emitting protein and a green light emitting protein. So what you're looking at there is a little cartoon of a molecular machine, a sensor. I'll see if I can get this to work. So when the target is present, it makes that sensor change shape and size. So that sort of thing happens. And when it changes shape and size, because of the physics, the ratio of blue and green light changes. And we can measure that. So how do we measure it? Well, we built a machine, we call it the Cybertone, that will measure the ratio of blue and green light and tell you how much of the thing you care about is present. Now, I could take any one of you in this room, give me 30 minutes, I would train you to use this machine, to be able to do that test in minutes in this room, and to do it not only faster, but better and more accurately than the person in the white coat with the huge equipment. That's how powerful the technology is. And under the hood, there's a lot. So there's actually 6 whole patent families which the technology was developed by the CSIRO. We've licensed that into our company. So obviously don't have time to take you through that today, but there's a deep technology behind that, and the opportunities are enormous. So here are just some of the relative market sizes for the need for this sort of testing in different sectors of the economy. Human health diagnostics is the biggest. We are going with food diagnostics because there is a big need there, and there's less competition. But the really important thing is that the barriers to entry in terms of regulation and the cost to get there are much lower for the food diagnostic industry than the human health diagnostics. Now, I am running a business, so we have to make money, and so any of you who have ever bought an inkjet printer or inkjet cartridge will know what we're on about. Yes, we will sell boxes, but we get recurrent revenue from the sales of the proprietary reagents, our inkjet cartridges. So that's what we're on about, and we're here to deliver laboratory quality results in minutes for the food industry, for human health, for the environmental testing industry, and pretty much anywhere else that it matters. And this is a technology developed in Canada. Thank you.